Hello students. Today we are discussing chapter number 1 real numbers of 10th class CBSE, and in this session we will discuss only the NCERT portion. So first question arises is, what is the meaning of real number? So firstly we will start with number system, and after that we will discuss one by one the topic of this chapter. Okay, first number system. First point is a natural number. Natural number represented by capital N. Natural number means countable numbers are called natural number. Countable means your school roll number start from 1. 1, 2, 3, 4. Countable, जिनका counting कर सकते हैं हम लोग. This is called natural number. So natural number is like this. Okay, 1, 2, 3. Second one is whole number. Whole number represented by the symbol W. If we include 0 in the natural number, then it is called whole number. Next one is integer. Integer represented by I or Z. There is a two option. All natural numbers and their negatives including 0. All natural numbers and their negatives including 0 is called integers. Next, rational. Rational number represented by Q. A number which can be written in the form P by Q is called the rational number, where P and Q are integers and Q is not equal to 0. P and Q are integers and Q is not equal to 0. This is rational. Next one is irrational number. Represented by T. A number which cannot be represented in the form P by Q is called irrational. Means एक दूसरे के just opposite है. Rational means जो भी number P by Q form में आ सकता है. Rational, and a number which cannot be represented in the P by Q form is called irrational. If we combine the both rational and irrational, then we can say it is real number. So real number means real number represented by R. This symbol R. Okay. In short, we can say R is equal to Q plus T. Q plus T means clear? Means rational and irrational, combined form of rational and irrational is called real number. So real number is clear. Now few more questions are: even number means a number which is divisible by 2. Odd numbers means a number which cannot be divisible by 2. And prime numbers. Prime numbers means a number which has only 2 factors. Examples 2, 3, 5. These are called prime numbers because 2 has only 2 factors, 1 and itself. A number which has only 2 factors is called prime number. Okay, and the next we will start chapter 1 real number one by one. Topic number 1 is theorem 1.1. So first topic of this chapter is Euclid's division lemma. This is theorem number 1.1. It's very easy. Given positive integers a and b, there exist unique integers q and r satisfying a equals to bq plus r, and r is always like between 0 to b and equals to 0 but not equal to b. We can easily discuss about this. A equal to bq plus r and r is always lie between 0 to b. How? See here. Suppose one example is 11 and 2. These are the two numbers. 2, 5 is 10, remainder is 1. See here in this condition, 2 is less to 11 and now 2 is divisor and 11 is dividend. Similarly here this remainder in question. So we can say this remainder is always lie between 0 to 2. 0 to 2. Equal to 0 is possible but not equal to 2. This is the condition. Okay. So this is called Euclid's division lemma. So first question, again a new question is, what is the meaning of lemma? A lemma is a proven statement used for proving another statements. This is already proved now. So we can use in another statements for proving the another statements. Next point is algorithm. An algorithm is a series of well-defined steps, means step-by-step process, which gives a procedure for solving a type of problem. We will discuss here. Question number 1 of exercise 1.1. Use Euclid's division algorithm to find HCF of there is two numbers 135 and 225. Firstly, check which is greater. See, 225 is greater. So since 135 is less to 225, so 135 is divisor and is dividend. You can see 1 time 135, remainder is 90. Now see, 90 is less to 135. Then suppose 90 as a divisor and 135 as a dividend. This is a process of Euclid division. Now 1 time 90 1 ja 90, remainder 45. Now see, 45 again is less to 90. It means suppose 45 as a divisor and 90 is dividend. 45 2 ja 90, remainder 0. So remainder 0 is possible in this case. So 45 is the HCF of two given numbers. This is called HCF. Means जिससे रिमाइंडर 0 आ रहा है, जिस डिवीजर से, वही HCF है. अब इसको हम दूसरे स्टेप्स में भी लिख सकते हैं like this. 225 in this form. A means 225, B means 135, Q 1 and remainder 90. So 135 into 1 plus 90. See here, 225 is equal to 135 into 1 plus 90. You can see easily. 135 1 135, 135 plus 90, 225. Now on the next step, 135 here is equal to 90 into 1 plus 45. 90 into 1 plus 45. Now in the last step, 90 is here. Suppose this is A. 45 into 2 plus 0. 45 into 2 plus 0. So 45 is HCF. So HCF of two given numbers is 45. So we can use the Euclid division algorithm to find the HCF. तो easily हम लोग किन्हीं भी दो numbers के HCF इस एल्गोरिथम के थ्रू फाइंड कर सकते हैं. ओके, दिस इज द कंसेप्ट ऑफ यूक्लिड डिवीजन. सो इंपॉर्टेंट थिंग इज a equal to bq plus r, and the remainder is very very important. Remainder is always lie between 0 to b. Equal to 0 is okay, but not equal to b. Okay. Now question number 2 is show that any positive odd integers is of the form 6q plus 1 or 6q plus 3 or 6q plus 5, where q is some integer. Odd integers means, see here, 6q is even, plus 1 plus 3 plus 5. So 1, 3, 5 are odd numbers. So question is show that any positive odd integer is of the form. Now compare this by our Euclid division. See here, bq plus r. So b is here 6. So let small a be any positive integer, and b is equal to 6. If b is equal to 6, then remainder is always lie between 0 to 6. Equal to 0 but not equal to 6. It means remainder, possible remainders are 0, 1, 2, 3, 4, 5. And integer q is greater than or equal to 0, because q is quotient, na? So if we put one by one the values here, a equal to 6q plus r. In place of r, if we put 0, so we will get 6q plus 0, 6q, 6q plus 1, 6q plus 2, 6q plus 3, 6q plus 4, 6q plus 5. There is possible remainder 0 to 5. 0, 1, 2, 3, 4, 5. But according to the question, only odd. So see here, odd. These are odd. Because 6q plus 2 and 6q plus 4 are even. So any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5. Suppose in this question one more part is here. Also find the positive, any positive even integers. So even integers may be 6q plus 2 or 6q plus 4. So this type of question clear? Now the next question. Question number 4. Use Euclid's division lemma to show that the square of any positive integer is either of the form 3m or 3m plus 1 for some integer m. Any positive integer is either of the form 3m or 3m plus 1. And one important thing is here, square of any positive integer. So let a be any positive integer and b is equal to 3. Suppose b is equal to 3 here. If b is 3, then remainder is always lie between 0 to 3. Equal to 0 but not equal to 3. So possible remainders are 0, 1, 2 but not 3. 0, 1, 2. Okay. So by theorem, a equal to 3q plus r. If we put here 0, we will get 3q plus 0. It means 3q. 3q plus 1. 3q plus 2. These are the numbers. Now according to this question, we have to square of these integers also. So squaring both sides one by one. 1, 2 and 3. Okay. So first point is a is equal to 3q. Squaring both sides. And our target is only these number 3m or 3m plus 1. So there is 9q square. Can we write like this? 3 into 3q square. 3 3 is a 9. Again same. And suppose this is m. So here m is equal to 3q square. Okay. Point number 2. A square is equal to 3q plus 1 whole square. A plus b whole square is a square plus 2ab plus b square. 9q square is a square plus 2ab, 2 into 3, 6q plus 1 square, 1. Now see here, 3 is common. Yeah, q is also common, but according to this question, we have to take only 3 as a common. So 3, so remainder is 3q square plus 2q plus 1. Check, 3 3 is a 9, q square, 3 2 is a 6, q. Now suppose this bracket is equal to m. So this 3m plus 1, where m is 3q square plus 2q. Okay. And last point is a square is equal to 3q plus 2 whole square. Same again, a plus b whole square, a square plus 2ab plus b square. 9q square plus 3 2 just 6, 6 2 ja 12. 2 square 4. See, there is 3 is common, but this is 4. So can we write 4 is equal to 3 plus 1? 9q square plus 12q plus 3 plus 1. See, 3 is common. 3q square, 4q plus 1 plus 1. 3 3 ja 9, 3 4 ja 12, 3 1 ja 3. Suppose m. So m is equal to 3q square plus 4q plus 1. Alright. See here, this 3m, 3m plus 1 or 3m plus 1. So the square of any positive integer is either of the form 3m or 3m plus 1 for some integer m. Similarly, the question number 5. Question number 5 is use Euclid's division lemma to show that the cubes of any positive integer is either of the form 9m, 9m plus 1 or 9m plus 8. So starting will be same starting होगा यहां तक, बस स्क्वायरिंग के प्लेस पर आपको क्यूब करना है क्वेश्चन नंबर 5 में. तो क्यूबिंग करेंगे, क्यूबिंग के बाद जो रिजल्ट्स आएंगे वो 3 रिजल्ट्स होंगे अकॉर्डिंग टू द क्वेश्चन. सो यू कैन इजीली सॉल्व दिस क्वेश्चन. ओके, सो दिस इज एक्सरसाइज 1.1. In the next class we'll discuss the next topic 1.2. okay, thank you very much.